Hey everyone, this is James Delancey. I am reporting in as the hobby developer here. And in this episode, we're going to take a look at how to use FFmpeg to create a free, fully featured screen grabbing tool. FFmpeg is the back end of what's going on under most of the applications that you already use for screen sharing or video processing or cutting video or splicing audio and souping up audio, souping up video, doing the green screen removal. It's a really useful open source tool that's released under several different licenses. There are licenses that have you can get a binary, a statically compiled binary for Windows, or a distribution of Linux pre-compiled version that is using parts that have proprietary or other licenses incorporated, and so that's where the variability in the license comes from. But it's all open source product, and if you want to go with like an LGPL license, you can use like the Vorbis or WebM, I believe, codec to produce videos for YouTube. Or wherever else you want to post your videos. So, and this, without further ado, let's first take a look at what it takes to download and install FFmpeg to be used for this purpose, for free screen grabber. All right, let's fire off a Google search. First, I'll search for FFmpeg. I'll hit the website here. Let's blow this up so you guys can see it a little better. Why not hit the download button here at the front? Now here's something interesting. Notice that's a tarbz. That's a source code file. I'm not interested in compiling my own code, especially on Windows. I'm on a Windows machine now, but look at this. So let's say we have a Linux machine, which I use quite a lot. We have Debian, Ubuntu, build packages right here. Like a lot of your Linux distributions are based either on Debian or Cent or etc. And so they also have some of these packaged binaries. So Linux is covered. In the Mac world, we've got static builds. Static builds means that when you build a binary for an operating system and architecture, you have all of the libraries that are typically out there that are shared and linked to save in disk space, and the ability to upgrade libraries without recompiling all your binaries and stuff. The good thing here about static builds is that you can take these you can take the binaries that come out of the build and you can just drop them into like C:/Windows, or you can just drop them in a specific place where it's in your path, so that this is a CLI tool. When you're using this product in a CLI, or you're leveraging it through external system calls for other programming, you don't need to worry about its dependencies. It's all built into that single binary. And we have the same on the Windows side. And so I'm going to click here, 0 no. All right. And so this is the FFmpeg builds that are available. So it says here that this is like kind of an auto build service for Windows. Thank you very much. I appreciate this. You have releases here, which are done every 6 months, it says. And then a couple times a week, there's Git builds where they just take, the code that is in the master branch and just compile it for you. As long as it compiles, I guess it gets to show up here. I'm not going with that because I'm going to go with release. At least release has some kind of standardization about what kind of code quality and some, I guess, debugging has already been done. Some bug fixes have already been done. I'll go with 4.3. I'm on a Windows 64-bit architecture here. I don't know that there are any reasons to choose one of these over the other. This program never takes up so much RAM to need more than 64-bit. macOS, of course, at the latest version of OS X has, or it's called macOS now, has sunsetted support for 32-bit applications, so it's up to 64. You'll notice your PHP and your Python and your other programming language packages will also only be available in 64-bit for those. Similarly here, but Windows 10 still supports 32-bit, and perhaps the file size is a little smaller. It doesn't really matter. I'm going to take 64-bit. Now on linking, I was telling you a moment ago, you can go with shared linking, dynamic linking, I guess, where it's going to use DLLs in a Windows box or dilibs in a Linux box. We're not interested in doing that because that's just to save disk space. I guess if you had multiple versions of FFmpeg and you wanted to be able to link to those. You could save disk space by doing that, but or you wanted to upgrade granularly or something, we're not into that. We're going to go with static. Now the license here, H.264 and H.265 are your pretty outside of WebM, which kind of been brought along, I believe, by Google. H.264 is what X264 is literally what every phone has hardware to encode, decode today. It's in the peak of its life cycle, really. With X265, the next one coming, perhaps it looks like it's going to be the next one. That's also called HVAC. So X264 you certainly want, but you're going to have to go with the GPL license to get that. And that just means that if you modify this software that you need to reference, or if you use it in a product, you need to reference the authors. And I believe it's some kind of like copyleft license or something. So if you're not a developer, you don't need to worry about that. Click the button to download the build and save it. Now I use 7-zip on a Windows box, and on a Linux box, it's going to be something analogous. Maybe we're going to do gzip. Maybe we'll do tar-xvzf to open this. But anyway, I'm going to get a download, and I'm going to open it up. I'm going to bring over my Explorer window, and boom, there it is. So here we have the inside of the zip under, well, we've got licenses and readmes and things, but here we have the binaries under the bin folder. And what I like to do is just take those, copy those things, and go paste them within C:/Windows right here. And so I can just scroll to the bottom where I'm not clicking on anything, and I can right click and bang, there they are. Okay, right click and paste. Okay, here we are with a command prompt, and let's see if these showed up in the path yet. So ffmpeg, boom, there we have the version 4.2. I believe we downloaded 4.3. Isn't that interesting? Maybe I have another version of ffmpeg in my path. So you should see 4.3 there if you downloaded 4.3 with me. Well, as a better test, let's make sure ffprobe is there. This is used for gathering data about a specific MPEG. It can export as JSON, for example. Oops. And ffplay there for playing these videos, or after you build them, or just running filters to see what it's going to look like. You can run ffplay, and it will overlay on top of your desktop from the top left-hand corner of your screen in the actual resolution of what you have just put together. And so that's one way if you want to just add some filters to see in real time what you're about to get before you go through a long re-encode process. You can do that, and we'll talk about that more in other episodes about ffmpeg if we do those. Okay, so next I'm going to show you a command line to be able to do your screen capture and save it to an MP4 file, which is the X264 format we were talking about earlier. Well, we've specified it actually specifically up here, libx264. Let's take it from the top. So this command will also work in Linux. One thing you're going to notice on Windows is that you can only use the double quote, so there are filters and things that need to go in and be specified by strings, and that's how you separate whole strings without the spaces needing to be escaped. So within a command line or Linux. Okay, so ffmpegs are binary here, and now we have a buffer size. I found this on, so the goal here is to prevent frames from being lost, because this is encoding as we go. It's writing it to the hard drive. It could write it in a less compressed format, but what we're trying to do is use a standard MP4 container, which is what everything will open and run, and X264 codec, and we want to do it in a way that it's not going to bog down the computer that we're on or make us lose frame. And there's two things we can do with this. One, we can stream this out directly to Twitch if we're like a game streamer. I'll do that in another video. We can stream it to YouTube for live YouTube or a live Facebook video, Facebook Live. So all of that's possible here based on the output that we choose. Now here we're set to write to a file. Okay, so we prepare our MP4 and container here. There's some automation there by it automatically looking at what kind of container we put by using the file type or suffix or the dot something, whatever you call that. So here we are setting a buffer size of 100 meg. The goal is to I'm not quite sure what that buffer is used for, but you can look it up if it's super interesting to you. I have a dual monitor setup, and so I have an offset of 1600 pixels to the right, none for the y-axis. That's x-axis, y-axis. So F here is setting FFmpeg to use a certain format for the input file, and that's going to be DGI grab. That's a built-in screen grab that is in the static binary, so you don't have any other dependencies on FFmpeg for that. Frame rate 25 frames per second, which is fine. I'm just trying to do the tutorial type recordings here. Video size. Now this is the size of my second monitor. That is the x-axis number of pixels in my first monitor, and that pushes it over, and it only records my second monitor, which is what you're looking at. Draw mouse. This is so you can see my mouse. And now -I, which is input, desktop. So this is an input called desktop of the type GDI grab. So similarly, we have audio on here. I'm recording my audio on another box, but I use this audio to sync it with the video. And so I have DShow, which is similarly picking up the audio. So the input file is called audio equals microphone, whatever. And that's going to be specific to maybe the driver that your microphone is or sound system is running off of, Sound Blaster, whatever. And now we're talking about output after this. So this is setting video codec as libx264. That may be the default, I'm not sure. Preset is ultra fast. This produces a big file, but it does not put a lot of pressure on the compute capacity of the machine to compress the file. And this is similar to what you're going to see in a lot of like GoPro type cameras or security cameras. They're going to be really huge files and very low compression. And that's what's going on here. And now tune zero latency. I'm not sure what that is. It's an FFmpeg preset though. And this is a signal. This is a quality, a compression quality. So 25 means that it can be very lossy. So as this there's like sane values for this libx264 codec, and they're between 18 and maybe 25, 28 or something. So 25 is what I've seen recommended to use for the screen grabs, and you can't tell that there's really a lot of data pulled out. So I think it does a good job. And then the pixel format. So this is a pixel format that is backward compatible, or I guess it's compatible with older stuff. So you might see other pixel formats being used, but if you use this, you'll be sure that this will play on like iPhones and phones and stuff like that. It'll play in the older media players like Windows Media Player and things like that. Okay, and then the file name. And then the suffix of this file name is important because MP4 lets us know the container type. It could be MKV or other things. So when I press the return key, it's going to start recording. But since I'm actually using another command prompt to record this session that I'm on with you right now, I'm going to let you see what that one looks like as it's recording. So let me pull it over. Okay, here we are. And this is recording, and the terminal is too small to hold the whole line on here. And the way this works is it shouldn't actually be line spacing every one of these. Every second or so it gives you a status update here, and it's given us like what frame number we're on, the frames per second, actual frames per second. The queue, I'm not sure what that is. The size of the file so far, we're approaching 80 megabytes. The time, it's about at 19 minutes right now. The bit rate, and the number of duplicate frames. So how many frames are dropped. You don't want that. That's going to be your CPU is going to be bogged down, or maybe you need some buffer so that your CPU can burst or something. And then speed, of course, run 1x because we're recording this in real time. Yeah, so of course if you have when you're transcoding though, and you're going from one file to another, the timestamps are in there, and so the computer can go ahead and process that really quickly because it already knows how to sync time and the audio and video or whatever other streams are in that container format. Here it has to run at 1 because we're taking this at real time. So if this was bigger, it just would not keep moving, but it's kind of ugly. So if your screen's big enough, and I pump this text up so that you can see it on YouTube, but if you notice here, this is not moving anymore because I think this terminal is erasing the line ending every time and then repainting every second. So it looks like it's just updating in place. So that's what's going on. Okay, so then like how do we look at this video when we're done? Let's look at a video. So we again have this test.mp4, and here it is, the test.mp4. Now I'm using VLC. It's a GUI based player to watch this. That's because I can move it around the screen pretty easily. I could use FF Play, but it's going to play in the monitor that you cannot see. And so rather than spinning wheels to set that up, which could be done, I'll play it here. And so here you are. You see it recording. I recorded this right before so that I could show it to you. There we are. And so I can hear sound coming back from this. And so the sound's there. And the sound's as good a quality as it would be on your computer. And you can set, the sampling rate 4800K or whatever you want, 48,000, right?